So welcome to this session on machine learning application in financial trading and investment. This is one of the workshops we hold related to what we call AI application in finance. Okay, so this workshop is going to be one of the workshop series that we are going to hold on the application of AI in finance. My name is Abubakar San Ali, and I am happy to be the one who will walk you through the workshop today. So, as a disclaimer, what we're going to learn today is basically for educational purposes, and it's not a financial advice. So, we advise those who will attend these sessions to seek an advice from their financial advisor with regards to uh, financial investments. So, our agenda for today, I will start with an introduction, after which I will give the basics of machine learning for those who are new to machine learning. Then I will also discuss some few case studies and success stories where AI and machine learning have been applied in the financial arena. After which we will see a trading strategy that is going to employ AI to enhance the performance of the strategy. Then we will look at our bot building framework, and this bot building framework is always used for us to be able to build our bots that will be doing trades for us automatically. And after which we will see a live demo where I will walk you through my process of building bots without code. Of course, you can build the bots with code, but if you don't know how to code, you can use the procedures I'm going to show you. And by continuously having discussion with the chatbots, you will be able to obtain a good code that you can at least execute and run. Maybe backtest it to make sure it is working. Test it also in a paper trading account before you deploy it in live. So, and once we are done with the demo, I will open the floor for Q&A as well as provide some insights into the next steps. However, I will say if you have a question during the course of this presentation, you can just raise up your hand and I will be able to address your question. And that's because if you leave your question till maybe the end, you might forget the question or you might have maybe more confusion in the following slides. So if you have any question, just raise up your hand and I will be able to address your question accordingly. So once again, you are welcome to this session, and my name is Abubakar San Ali. I will be the presenter for this workshop. I am a PhD graduate with specialization in electrical and computer engineering. I've had different use cases and applications. I have done lots of projects related to that using AI, okay, and machine learning to solve different real-world problems. The host institution is called Asataura Services, registered in the United Arab Emirates, and we provide consultancy services, training and workshops, just like this one, as well as research and development. So for those who are interested in doing some research works, especially those related to AI and machine learning, we are happy to have you with us. So our goals for today is to see how we can use machine learning. We get to understand machine learning and AI. Not only that, how it is applied in trading and investing. Once we have this, we will see some real-world case studies that showed how AI was able to increase the success rates of different organizations in terms of win rates in the investment and the trading strategies. Then we will see how we can build. Here we want to explore how to build and implement a trading bot using decision tree classifier. So in the previous two sessions on Monday and Tuesday, we saw how we can build a trading bot that uses linear regression. So today we are going to see how we can use classifiers to do that. So for those of us who are new to trading, this is something that I should also mention, that trading has three components. That is the strategy, the psychology, and the management. The strategy deals and is focused on the basic rules you follow to execute a trade. Okay, and the psychology is about your emotional state during making that trade. The management involves how you manage your resources, that is your capital. So what are the procedures as well as strategies do you use when you are managing your account or your capital? So building on that, we have what we call the algorithmic trading, which is a special type of trading. By default, trading is done manually, where we go into the marketplace with our money, look for an asset or a product that we want or service, and then we exchange this service with our cash money, or we do a trade by barter. In the case of algorithmic trading, normally we are talking about buying and selling of assets in the financial market, where the computer is the one that executes the trade on our behalf. So we are not going to be executing trades manually. And these algorithms are going to follow a certain timing and pricing that we are going to implicitly explain to it explicitly. Our aim is to execute orders at the best possible prices so that we can reduce the impact of human emotions on trading activities. As you know, or as I've mentioned in the previous uh, workshops, that from the data, scientific data that was obtained, 90% of success and failure rate is related or associated with emotional states of traders. So if you can reduce this impact of emotion, you are guaranteeing an increase in your success rate. And that's where the bots come into play. First of all, they provide us with speed. We can't compete with computers in terms of speed and efficiency. They are also consistent and they are very displayed. So once you set, let's say, your risk management in place, they will follow that risk management plan and they will not deviate. They also help you to make sure the risk management is highly improved. Not only that, they allow us to backtest our strategies. So robots can go back in time, meaning if you have historical data, you can train them or you can test them using that historical data so that you can see how they will fare in the real market. Human beings, we cannot do that. We can only develop our strategy, then test it in the current time. We have enough time, maybe 100 years, 50 years, 20 years to test our strategy without having to get bored, you know, then we can do that once we develop the strategy. But with robots, you can go back 10 years, 20 years, 50 years back, and then test them to see how they were faring in the market, and you can get your result within seconds. So with that, you can use it to pursue or update or modify your strategy. Lastly, scalability. They bring the benefit of scalability into the picture, where you can have multiple robots working on different assets, you know, and instead of you to be the only one monitoring your assets, you have this huge army of robots, each one working on a different asset. And that's something we cannot do as humans. We can't be at, the same place or at different places at the same time. So now coming to machine learning, okay? So somebody might be asking then, okay, we understand how to buy and sell, but how is machine learning going to help in this regard? So to make some few things clear, when we talk about machine learning, we are talking about a subset of artificial intelligence. Artificial intelligence comes in different shapes. We have uh, different fields inside artificial intelligence. Things that have to do with, for example, natural language processing, evolutionary computation, even robotics sometimes is counted as AI, search algorithms, all these are sometimes considered artificial intelligence, whereas machine learning is just one subset of AI. We also have the deep learning. So you might be hearing about deep learning. If you have machine learning, it comes with different, it comes in different shapes, different types of algorithms. And these algorithms are kind of, let's say, a teaching methodology which teachers use. So you have different teachers, each one is using a different teaching methodology. And one of those methodologies in machine learning is called deep learning. This is based on neural networks. These are systems that try to mimic the way the human brain works. So how our brains are connected. So using that as an idea of interconnection, these algorithms were developed and they were able to do wonders for us. All right. And for those of us who have used these chatbots and what have you, I'm sure if you have used ChatGPT, Google Bard, and the likes, you will be able to experience the amazing stuff these models can do. So that is in relation to deep learning and AI. Then what do we, how do we define what machine learning is? So in simple terms, machine learning is a collection of systems that learn from experience. So if you have systems that you can give some data, here experience is data. So historical data is what we talk about when we are talking about experience in this regard. So if you have the data, it will look at the data and it will try to learn some patterns from it without you having to explicitly program the behavior you want to see. In traditional programming, we normally tell our computer instructions which it will follow step by step. Tell it if this happens, this is the result, and sort of like that. But with machine learning, all you have to do is to give it the historical data and it will be able to figure out how things work on its own. And some of the applications that you are aware of include email filtering. So if you have, let's say, your Google folder, you open your Google or Gmail account, you will be seeing different folders. You have inbox, spam, promotion, social, and stuff like that. That's email filtering. It's done by a machine learning algorithm. They do not have somebody, there is no human being who sat there trying to sort out your emails as they come. So they train an algorithm to be able to mimic that human operation of email filtering. Speech recognition. If you use Siri, Cortana, Alexa, this technology. You speak to the computer and it is able to understand your speech and give you a response. Predictive analytics. This is a type of machine learning application where we predict something that is going to happen in the future. And one of the key applications of predictive analytics is to predict stock price. We are trying to predict stock price or maybe forex assets, euro, is it going to increase or is it going to fall? So this is predictive analytics. Some of prominent real life examples are listed here. The first one is about the usage of AI and machine learning in retail industry. So there was a case where Target were sending this lady pamphlets and flyers regarding baby products, and her dad happens to receive this mail and went to the branch to complain to the manager that why are they sending his teenage daughter things that had to do with pregnancy, only for him to learn later that his daughter is pregnant. So this is one way to show that machines were able to identify something that a human couldn't even tell. And how did they do that? It is from her shopping history. They look at her shopping behavior, look at her, what is it that she was normally browsing on, what is she checking, and based on that the machine learning algorithm came to the conclusion that she might be pregnant. Obama used AI and machine learning or data science during the 2008 and 2012 election cycles, and he was able to access information on friends of his followers. So if you follow Obama at that time, that means you are a potential voter who will vote for Obama. So it is likely that your friends within your cycle are also going to vote for him. Therefore, all his campaigns started to become targeted to those people. and that made him succeed. One of the reasons why he was able to win. So this is the main point, okay, of machine learning. This is the main take home. When you have machine learning, it comes in three shapes. You have what we call the supervised learning and the unsupervised learning. Not only that, we have a more complex form of machine learning called the reinforcement learning. In the case of supervised learning, here you have a teacher who kind of monitors the learning process. Okay, so if you have a student who is trying to learn, let's say, mathematics, and then there is a teacher who is teaching that student algebra. So when the student is able to solve based on the examples given to him by the teacher, he also has access to the answers, so that if the solution is wrong, the answers he will check will be wrong. He will see that, okay, I got the wrong answer, then he tried again. So that means both the answer and exercises were provided during the learning process. Okay, so with the examples and the answers, this student is able to learn and come up with a model. Whereas in the unsupervised learning approach, only the examples are provided but no answers. Okay, no answers. So the teacher only provides the examples. Okay, look at the examples, but there are no answers. On your own, try to figure out how things are related. Is A and B related? Yes or no? So that is something for the student to figure out on his own. Furthermore, if you look at reinforcement learning, it takes things to the next level. Here, the student tries to learn on its own. So the examples are not provided, talk less of the answers. So we just allow the student to go and figure it out on himself, by himself, and he learns by trial and error. That's the reinforcement learning approach. So supervised learning comes in two shapes. We have what we call regression and classification. So regression tries to predict numerical values, okay, continuous values, for example, house prices. Okay, so if you have a real estate agent who is trying to predict or who is trying to teach an intern how to value houses and price houses, you can take him out on a to go around to see some houses. Okay, then he will tell him, okay, this house has this number of rooms situated in this neighborhood. This neighborhood is a good neighborhood. It has very low crime rate. For this reason, we are valuing this house at so price. The prediction is continuous. Okay, so this is a regression problem. When you predict stock price, when you predict the price of, let's say, crypto in the next 2 days, 1 year, 1 month, you are making a continuous prediction because the prediction comes in numerical form. Whereas if you are talking about classification, which is the second type of supervised learning, here we are predicting labels or categories, okay, categorical values. So it's like having images, and you want to tell the model to understand how images of cats differ from images of dogs. So what you do is you bring an image of cat, tell it this is a cat, tell it this is a dog. You keep doing that until when the student can figure out how a cat is in terms of features, facial features, body features, and stuff like that, and how it looks like in terms of those features. So we can use classification too in finance, where we try to see, given some features, let's say technical indicators, RSI, MACD, Bollinger Band. We want to classify whether the opportunity that is going to be presented to us is going to be a good one. So we are going to say, okay, buy or sell, go long or go short. Are we going long or are we going short? So this is two categories. We are not predicting the price. Okay, this is the difference. In regression in finance, we want to say, okay, given the features, okay, let's say I have moving average, I have RSI, I have MACD, I have Bollinger Band. These are their corresponding values. Most likely, price of Tesla is going to increase from 200 to 240. I have predicted the price it is going to reach. by the end of the day, 240. Okay, why? Because at the open of the day, these are the values of these indicators. However, for classification, I will say, okay, given the RSI value, Bollinger Band, whatever, there is a possibility the price is going to increase, so I want to buy. So here I'm not telling you this is going to be the exact price. I'm just telling you buy Tesla, sell Tesla, buy Tesla, go long, or sell Tesla, go short. However, in the regression, we are even predicting the exact price we are predicting this stock is going to reach. So this is how, even though they are doing the same thing, but they come in different forms. At least with the regression, you know exactly where you are predicting the price to be, which you could be very wrong. But for classification, you just want to get a signal to go or stop. We will talk about unsupervised learning and reinforcement learning in common in the next 2 weeks. Tomorrow we are hoping to do clustering, and the coming week we're going to look into reinforcement learning, how this also are applied in the context of financial trading and investment. So the previous week we worked on regression. This week we're going to work on classification based strategies for trading. So machine learning in trading has been used immensely to enhance the accuracy of our predictions, and that is because it can process large data sets quickly. Alright, if you maybe look at historical data, as a human being, you can easily maybe make pattern recognition for maybe 5-6 days if the data you are given is, let's say weekly, and maybe for 2 or 3 futures like that. Adding more will become difficult for you to make this processing, and that's where the machine learning algorithms can be able to look and help out. They can look at so many things and come up with a pattern that will allow things to figure out the pattern within that complex situation. It has been used in financial markets to make price prediction, as I said, and also as a core part of algorithmic trading strategies. Not only that, you can use it for risk management and compliance. You can train a model so that it will be able to identify for you the right take profits, or the right stop loss value. So if you know these levels, you have further improve your risk management. It can tell you maybe if stock is increasing in this rate, most likely the take profit should be at this level, because it is going to be less likely that the stock price is going to go beyond this level. So once you reach that level, just buy it out. So you can use it in that regard as well. Because of these benefits, because of these features and functionalities of AI and machine learning, traders use it to enhance their decision making, so that they use data to come up with final decisions. Of course, in terms of emotional bias, we can easily tell that by allowing data to do the talking, we remove the impact of our own emotions from the trade. For that, we can also say, since we are automating it using computers, the execution speed is expected to increase. And in real life, it has been used by the big guys in Wall Street. Renaissance Technologies is very famous when it comes to algorithmic trading and using machine learning and AI, as well as other statistical and mathematical models. BlackRock, the biggest company in the world that has the highest asset under management, they have a system called Aladdin that they use to predict and determine which companies to invest in. Citadel, they have developed a high frequency trading bot that trades in milliseconds. Some people even say microseconds. It goes in and out of trades in microseconds. Charles Schwab, they have this system that they use, a robo-advisor that they use to provide personalized financial advice to their clients. So you come and this system will be able to look into your records and give you the right advice that is personalized to you alone and alone. Yeah. JP Morgan too, they use it for their equity investments. They have a system called LockSM that they use for that. So as I said, so many companies are using this, including these big giants. So it is nice that we can also leverage and take advantage of this technology to also enhance our success rate in the market. All right, so I have reached the end of the introductory session. Next, I will start talking about trading bot building framework. So how do I build a trading bot? This is the steps by steps which I follow when building a trading bot. Before I start this part, if you have any question, you can ask. Otherwise, I will move on with this. Okay, in the chat, if there is any question, you can type it out. You can open up your mic and we can discuss this. Okay, so apparently there are no questions, therefore I will move on to the next part. So the framework. So when we are building, we need tools, and the tools we're going to use to build our trading bots in this workshop are ChatGPT Plus, Google Colab, Python libraries, and Alpaca API. The ChatGPT Plus provides us with a platform where we will tell and give a full description of our strategy and what we intend to do so that we can get executable codes. Why we don't want to write a code? So assuming we don't even know how to write a code, but we know how we can explain our strategy in a well-structured manner, then we can come to ChatGPT and we can give this structured strategy to the ChatGPT and tell it to generate the code for us. So it helps us in that regard. So once we get the code, we will use Google Colab. Google Colab is a cloud-based Python programming environment. So you need somewhere to run your codes, right? And that's where Google Colab comes into play. It is free and it helps and supports collaboration with other people. You can use it for backtesting strategies, can run complex simulations, and it supports all machine learning libraries. So you can run your machine learning stuff here as well as all the other logic in this environment. Comes with lots of libraries that support data analysis and visualization for trading insights. Then since we are going to code in Python, or we are going to build our bots using Python, then there are some libraries that were developed by other people to streamline that process. We do not want to be writing code or doing things from scratch for everything. We use these libraries to simplify our code development. For example, Pandas is used for data analysis and manipulation, NumPy for numerical computing and operations, Matplotlib library for data visualization and charting. You want to create some charts, use Matplotlib library. Scikit-learn is for machine learning and predictive modeling. So since we are going to use machine learning, you will see Scikit-learn in the picture now. The TA library, we have this for technical indicators. You want to use technical analysis and you want to use indicators such as moving averages, MACD, and what have you. Use this library. They provide you with all the codes that you need to do that. TensorFlow, as I said, machine learning comes in different shapes, and one of the popular types of machine learning is called deep learning. So to do deep learning, you can use a library called TensorFlow developed by Google engineers. PyTorch is also a deep learning library developed by Facebook engineers. OpenAI comes also with different supports and libraries. For example, it has the OpenAI Gym. This is for usage of for building reinforcement learning environments. Okay. It also comes with a natural language processing toolkit that you can use to implement natural language applications. Alpaca API. Okay, so now let's say we have built our code. We've gotten the code from Google ChatGPT. We run this code in Google Colab using those libraries to help us build the code. We are happy, everything is working. The next thing is we want to connect this to a real market, and to do that we need a brokerage account. We can go, if you have your own broker that you use, you can go and check it. But Alpaca Securities is one of the best brokers out there that support algorithmic trading. Some do not support algorithmic trading. Some they do support it, but you have to go through long procedures in order to do that. Some they provide APIs that are very expensive. Okay, for example, there is Owanda. The API is there. You can use it with Python, but you have to be paying monthly around $400. That is the starting price. Interactive brokers, they also have APIs which you can use, but you need $25,000 to start or open an account with them. So looking at all these constraints, we want to see if there is a possibility of having a brokerage account, brokers that do not charge for their API and that we can really use to access the market. That's where Alpaca comes into play. It's based in the US, New Jersey, if I'm not mistaken, and it's one of the most trusted brokers in this regard. They provide this API commission free, they do not charge for it. So that's why we're going to use it to use our to automate our trades. Okay, so the API is kind of the bridge between the brokerage account, okay, and our code. So this API is going to be used in the code to access our brokerage account. An algorithmic trading bot comes with 3 parts. Not just algorithmic trading bots. I think every trading strategy should have these 3 parts in place. Otherwise, there could be some huge consequences and repercussions. For example, we are talking about having the signal part. Without the signal part, there is no trading strategy. This signal part is what indicates the trading opportunity or an investment opportunity. It tells you this is the time to buy or go long or go short. Okay, so if you do not have this, if this is missing as a component, there is no trading strategy in the first place. The other type as well, this tells us, okay, once we identify or spot an opportunity, are we going to buy immediately or are we going to wait? If we're going to wait, what are we waiting for? Are we waiting for the prices to go down, or are we waiting for the prices to follow the trend which we are predicting the price is going to reach? If we are predicting things are going to go up, we are going to wait till they go up, and that is a stop order. But if we are predicting they will go up, but we want price to come down a bit, then bounce back, that is a limit order. But if we want to enter the trade immediately once we spot the opportunity, that's a market order. So you have to indicate this in your strategy. How do you intend to execute that trading opportunity? And then lastly, you have the risk management part. So if you go into the trade without any risk management, then you might fall victim of blowing up your account. So if you go into the trade, you should have an exit strategy. You enter, then how do you get out? So we have this strategy, for example, of getting out. So this is the take profit or stop loss. So if I am predicting price is going to go up, maybe Tesla is 200, I'm predicting it's going to go to 250, then I will put my take profit at 250. Once the price reaches 250, I go out of the trade. If I had predicted it's going to go to 250, but then my prediction could be wrong, I can set some stop loss so that if the price falls below a certain value, I will cancel the trade and get out, and maybe reduce my risk of losing all my money. So maybe I can put my stop loss at 150, so that if the price falls from 200 to 150, I am happy to take my $50 loss and go home agreeing to have made the wrong prediction. Position size, this is going to be the size of our position, which is the percentage of our account which we are willing to put into that trade. Are we willing to put all our account balance into the trade since we spot the opportunity, or we just want to put a certain portion of our account? So this is important. Ideally, based on studies, we do not want to put more than 2%. This is called the textbook position sizing, right? But if you are confident, like George Soros, you can even borrow money to go all in, you know? Yeah, the man who bankrupted the Bank of England. So now that we know of these components, then how do we intend to build it in our regard? So since we are going to use AI-based strategies, and as I said, today we're going to look into classification-based strategies. One of those is called the decision trees. Okay, decision trees come in different forms, but what we are seeing here is a simple decision tree. We have what we call the boosted trees, where you will have, let's say, random forest, XGBoost, light GBM. All of these are variations where you have collections of decision trees. But a simple decision tree is simple if and else rule kind of logic. So we are trying to say, okay, if we have a person, starting from the top root, if we know the gender of this person, is it male or female, and we know the height, we can classify this person as short or tall. Okay, for example, we get somebody who comes and this person happens to be male, who is less than 5'8", then this person is categorized as short person. Okay, but look at this. For the case of a female, it is categorized as a short female if the height is less than 5'4". Okay, so that means here the gender is important, a feature to categorize if a person is tall or short, as well as the height. So the first important feature is the gender. Okay, so you can say, okay, if the gender is male, then our threshold for short or tall is going to be different than when the gender is female. So this approach is what we call the decision tree approach. We will have this, so sometimes it comes in different branches and also with different levels. So let's say you have more stuff before you come to this. Okay, depending maybe also on nationality, maybe you can add another nationality. I don't want to maybe give an example. You can say, okay, if this person is from this nationality, okay, and he is male, and then this is the height, we can say it is short. You can add another thing as well, maybe body mass index, okay, maybe the weight as well. So not just the height. Before the height, we can now add weight, for example. Based on that, we can also add more. So the more features you have to make the decision, the more complex the tree gets. As a person, as a human being, maybe this is as good as you can go, But for decision trees, give it maybe more features. It will still try to figure out these thresholds, and it will still try to come up with a classification for a person, whether he is short, tall, or what have you. Okay, so this is how decision trees work, and how we intend to use it is we're going to use it for the signaling part. Okay, so we are going to give it bunch of features. Okay, these features are going to be 5 of them. I'm going to give it RSI. Okay, I will give it MACD. I will give it Bollinger Band. I will give it also macroeconomic. Those are technical indicators. You will have also macroeconomic features. For example, I will give it the inflation rate as well as the interest rate. So it will have these 5 features, and then it will be trying to figure out at this current time, this is the value of these features. The moving average is this, RSI is this, Bollinger Band is this, MACD is this, inflation rate is this, interest rate is this. What will happen to the price of this in the next 30 minutes if I'm doing a 30-minute trade, or that is I'm a day trader, for example, or 1 hour or 1 day or 1 month or 1 year, depending on my objective. Okay, so it is going to say, okay, most likely things are going to be good, therefore buy. Most likely, given these values of these features, things are not going to be good for this stock, so go short. Short sell this stock. So this is what I want to do. This is how I intend to get my signal. So I will give bunch of features. These features that I just mentioned, I'll give it to my decision tree, and I expect it to look at them and decide for me, you know, if I should go long or if I should go short. That's what I intend to do. So that is it. So what is the objective that I'm trying to achieve in this regard is to build a trading bot, okay, that is going to do, actually I'm trying to build a day trader, okay, a trading bot that will be making short-term trades. So by the end of the day, I will close all my trades, go with my profit, and if it is a loss, I take it and go. Okay, so that is my objective, a short term, to build a short-term trader. Okay, so I will tell ChatGPT this thingy that this is my objective. What is my trading logic? As I said, okay, if for example I will set a threshold, for example, so what I will do is I will have, let's say, yeah, I will train my algorithm with historical data. Okay, let's call this historical, let me just put 2 for example. Okay, so I will have this 2. Okay, let's say that SI, let me just put arbitrary values. Okay, so I will now look at it. Now this is the current time now. Okay, now this is RSI value, this is the MACD value. Okay, but I have my data already. Remember, I already have the history. I can see into the future from the data I have. Now let's say today is what, 10th January 24. This is the MACD and this is this. I know from my data by the end of today, when the market closed, okay, the closing price, let me put close, okay, is gonna be, let's say, this is Tesla for example, it's gonna be 200. Okay, however, do in the morning when the market opened, okay, when the market opened, it was 180. I know this from my history, because I have this data. Okay, so I can make a label, for example, if this is the current time, this is at the close, and this is the open, this is of course going to say what, buy, right, or go long. Okay, so I will make this labeling like this. All right, for this one, let's say the open, I should have put the open here, but anyways I already do it. So let's say now yesterday it closed at, so this is 11/1/24 for example, and we know that it opened at 200 because yesterday it closed at 200 for example, and the price was 190. So we can see that this is falling, right? So of course what we would like to say, this is going to be sell or go short, so if this is the opportunity, so this is going to be the table. The idea is I will just give my decision tree these values. Okay, just give it these values of the RSI and this, and I will tell it to predict what will go. Of course I will also maybe give it the open, and I will tell it to predict what is going to be the close price, what is going to be this value, and based on that I will set a threshold. If for example the close is going to be a certain percentage greater than the open, then that is where the buy comes into play. But okay, so this is going to be like a threshold. I will set a percentage threshold. I want to make sure I will have, let's say, 2% increase. Okay, so whenever I see RSI 11, MACD 22, it is likely that if the closing is 180, the open is 180, the closing could increase by 10%, and 10% of 180 is 18. So that means 180 plus 18, that gives me 198. This 10% is greater than the threshold which I set, which is what, 2%. Therefore, I'm gonna buy. So I will just buy. Okay, so this is my logic. This is what is going to happen. Another thing that I would like to mention is I will also like to see if I spotted this opportunity and I am already inside the trade. Okay, I already bought Tesla because the previous candlestick told me to do that based on my model prediction. Then I will just hold. It is just telling me to hold because it is also telling me now again in the next 30 minutes buy again. So by saying buy again, it is just telling me to hold. But once I was I was into it going long. Then the next 30 minutes it says sell. This is an indication for me to get out of that trade. Okay, I see sell now. Well, I was inside this, then I'm gonna get out of the trade. This is what a red signal, go out. But if it tells me to buy again, it is just telling me hold on to my current position, do not sell. If within the 30 minutes time frame my TP or stop loss is triggered, then I'm gonna go out of the trade. So then the question is, how do I intend to put the stop loss, which I will talk about. But before I move that, once I get this signal, how do I intend to enter the trade? So for the sake of simplicity, we are going to place market order. Okay, we are not gonna use limit order or use the stop order. Once we spot an opportunity, we are going to go into the trade. For the risk management, we're going to use ATR, average true range, so that we can introduce adaptability into our stop loss and take profit. So what ATR does is, for example, in this strategy, what I intend to do is to see if, for example, at the time I am going to buy, at the time I enter the trade, let's say ATR is 0.5. Okay, so I will put my TP at 0.5 times, let's say 3, which is 1.5, and I will put my stop loss at 0.5 times maybe 1, which is just, let's say, or let me say times 2, for example, which is going to be 1.0. And let's say the price when I enter is what, 200. Okay, that is $200. So then my TP is going to be 1.5 times 200, and that will be, let's say, 300. So this is how I'm going to exit. And this one is, let's say, 1 times the, the difference is going to be, let's say, yeah. So this is going to be less because this calculation, do not mind me. So what is going to be the multiplier? This is 200, is supposed to be times 3. So this is supposed to be 200 times 3. Okay, because multiplier here is 6. Okay, so 6. So yeah, because this, if you take it, so this I'm talking about it to be double, which is double down. Okay, for example, so let's say 100. So if the price goes down to 100, I'm gonna go out of the trade. If it reaches 400, I'm gonna take out and go with my profit. This is just how it works, but it keeps varying as the time goes. The market conditions change, ATR keeps varying. That's why it is nice to have ATR. It adapts to the market conditions. Okay, forgive me if I miscalculated there, but anyway, the computer will do the calculations, right? Okay, so the framework I'm gonna follow, this is my framework. Initially I start by making my environmental setup. Once I have my environment ready, I will build the trading strategy. And this here I will talk to my model, my chatbot, tell it what I am thinking and how I am defining and describing my strategy. Once I see that it understood everything clearly and there is nothing missing, I will go ahead and use the machine learning process. And the machine learning process, before, we do not have this part. Okay, before we had only 2, 4, 5, 6, so which comes from 1, 2, 3, 4. Now we added 2 more parts with the machine learning process. We have machine learning process because we need to do machine learning training and what have you. Once we have trained the machine learning and our strategy is well understood and we get the code for the strategy with our trained machine learning that learned from historical data, we put this together, then try to test how good are they going to be when we put them. So we will test it If we are happy with the result, we will now deploy it in the market. Of course, we will connect it to the market using the brokerage or the Alpaca API in our case. And then we will automate the trade so that it will keep on running automatically without our need to engage with the system. The machine learning process is as follows. We start by collecting data. It needs data to learn from from that experience, right? You need the data. So we will collect this data. We will prepare the data. After we prepare the data, then we will choose the model. As I indicated earlier, depending on the problem you are trying to solve, if you are trying to solve a regression problem, there are specific algorithms that are meant for that. Classification problems have their own algorithms. You can't use classification, algorithms to do a regression problem. You have to pick the right one. So in our case, we've already decided to go with decision tree. Once we have these three things in place, we have picked the algorithm, we have picked that we have our data, then we will put these two together to train the model. You can say the model is the student. So we have the teaching methodology to teach the student as well as the exercises and examples and what have you to teach. Then we just start teaching. After we finish teaching, we want to see how good is the performance of the student. Did the student really understood the concepts, in this case the pattern within the data, or it just memorized the contents without any proper understanding? That's where the evaluation comes in. If we are happy with the performance of the student, we might say, let's deploy it. If we are not happy, then we will tune. Okay, maybe change some few things. Look at our training methodology. What can we change? What can we tune to some extent to improve the accuracy of our learning process? So this is the machine learning process. Once we have this in place, we will now have our bot working. So with this, I will start working on building the bot. And I try to, as I said, I will try to do this with no code. Hopefully, I will not type a single line of code. I will just be copying and pasting. Unless if maybe we have some few things which I hope not to be the case. Okay, if there is a question, please go ahead and ask, because I think we have reached another milestone. Now we're going to go into another section of the presentation. Okay, there is a question. Okay, please go ahead. What's your question?
On the first workshop you had, you recommend Google Bard, but today you said ChatGPT Plus.
Yes.
You've had a change of heart about it?
Yeah, the reason being, Google Bard, as I said earlier, is free, right? It's free. You get it and you use it, and it's good as a tool, as a free tool. Okay. Why did I change to ChatGPT Plus? Is because with Google Bard, it needs a lot of to and fro. Once your strategy becomes a bit complicated, so it will be generating new code sometimes, and there will be errors. You have to go back and forth with it to be able to get the best code that will work. Okay, ChatGPT Plus currently is the, I will say, most accurate large language model out there. So for the sake of the workshop and time, I do not want to be haggling with the large language model until I get the right code. With ChatGPT Plus, most of the time when I tested it, I get the code working from the first instance. It will give me the code. That was the reason that I switched to ChatGPT Plus. It's for the sake of okay, but you can still use Google Bard, no problem.
I have ChatGPT Plus because I was following along with you, so we'll see how it goes. Because I remember you did have, it wasn't as fluent when you were doing Google Bard, so I remember that. So let's see how ChatGPT Plus works today.
Yeah,
okay,
it does work well. I've realized that for the sake of time, we do not want to be haggling with Google Bard. So another question, or we can start?
More like a comment for me. Comment / I'd like to do it with you. So
Okay.
I'm set
So
up to
how
do it
do
with you.
we do this?
Questions in between.
Yeah, that will be nice. Do you want to share your screen as well?
So I'm sharing what I'm doing. I have Zoom on my phone and I'm doing it on my computer because I didn't want to have um to miss out on anything you were trying to show on the screen.
Okay.
If
Okay.
needs be, we could
So
perhaps share.
we can do one thing. I will be sending the prompts in the chat. Okay.
Okay,
Yeah. So the prompts for each step, I will send it to you in the chat, and then you can
okay,
paste it in GPT, and it will be able to generate the response and the code for you. Using that, you
got it,
can execute it. Okay. All right.
got it.
So I will share my screen now. Okay. So I have my two tools or three tools that I'm going to use. Let me close down this. The code from yesterday. So I have Google Colab here. I have my Chat GPT here, and then I have Alpaca here. Okay. So you can open your Alpaca account, and you can sign up. It's also free. As you can see, I'm using paper trading account. No real money is used. And if you have your Alpaca account, how you normally go about it. Okay, these are all the trades we executed in the previous days during the previous workshops. Okay, so normally in Alpaca, you have the option to put your trade. For example, can pick Google and check with Google. I can indicate the order type. Can indicate maybe based on my, I have let's say $1,000. I want to put 10% of $1,000. That's $100. I will say review order. I will confirm the order. So this is how I can do it manually. I can come here, look at my list of orders. This is the one I bought just now, $100. Okay, you can see this is the chart. If I want, I can add all those indicators I was talking about. Bollinger Band, for example, RSI, moving averages, they come in different shapes. Okay, for example, the RSI and all that. If I want to cancel, I come here, I cancel it, right? Just do this and can cancel this order easily. So these are my orders. Okay, can review order. This is the information about the order. Okay, all right. These are the open orders. None, closed. Okay. And this is the only order we placed today. Okay, so our idea is to see how we can do this manually. I will start with the environment setup. Always my first step is to install my libraries. Okay, I will put this here and I will send this in the chat. You can run it in Google Colab and it should be able to work. It will install everything for you that you need in terms of libraries. You can see it in the chat. Okay. Maybe in the meantime, I will change the name here. Let me put demo code. Today is 9/20/24. Okay. Yeah. So some are already installed. As I said, Google Colab comes with so many things already installed. That's why you see this requirement already satisfied. So many of the tools are already installed, so no need for them. Okay, so the next thing to do here is to go to our chat GPT and try to test connection. Okay, so I'm going to do something like this. I have my prompt. I will also send the same thing in the chat. Okay, I sent it in the chat. So what did I say? I told Google ChatGPT, I want to build a trading bot that will trade Amazon stock. I want to use Alpaca API to connect to the market. I've installed all necessary library requirements. I'm using a paper trading account to test my strategies. Test the connection, start by executing a market order on Amazon. Let the trade run for 10 seconds, then cancel the order. Okay? So it told me what it understood. It is now trying to generate a code for me. So sometimes you might tell it, you know what, write the code. So in order to connect to the Alpaca API, you need to get your own API keys. Okay? Go to your home page, scroll down where we place that order manually. On the side, you will see view API keys. It is the first time you are opening Alpaca account. It will be open or create API keys. Okay, once you click there, you will see your API keys. You see the endpoint, you see the key. Okay, there will be a third value, which is the secret. Make sure you copy all these three values, save it, okay, in a Word file or a notepad so that you can use it in the code it will generate for you. So this is the code it is generating. Here it is telling me your API key, which I just copied, your secret key, which I just copied, and then the base URL. Already this is the base URL. The same thing with that of Alpaca. It already knows this is what Alpaca uses. So what I will do first, I will copy this code that it provided. Okay. I will come to Google Colab. I will paste it. I will go and copy my API keys. I will come here, your API key, paste it here. Control V to paste. I already stored my secret. Get my secret, copy it from my Word document. I will come here and I will paste. So now I have it here. So let me, yeah, I want to see the order. So what I did was to test the connection. So I'm going to place an order here. It's going to buy 1 share of Amazon. So let's see, is it going to do that? So let's monitor here. Let's see the code. What will it say? Can it place the order? Aha, Amazon. You see, filled 1 share. It is going to stay there for 10 seconds and then it will cancel it. That's what it said. Order placed and cancelled after 10 seconds. Okay. So we are happy. Our connection has been established. We can place orders from our coding environment and it will get executed on our brokerage environment without having to go and be doing those stuffs by hand. Awesome. So now that we got this done, the next step is to now, yeah, let's see what the next step. Okay, we've set up the environment. Happy. Now the next step is to build the trading strategy. So by default, I will explain my strategy to ChatGPT. Okay. So I already have it written down to facilitate this process. Can you hear me? Okay. So I'll paste this here.
इधर से उठा
Okay. So as you can see, what did I say? Let me send it also in the chat. I hope it will go. Okay, it's too long. So I will split it into three. Okay. Okay, I've sent you the first part and the second part. So put all this together in the same prompt and run it through. Yeah. Okay, so let's see. What did I say? Okay, the details of my strategy are as follows. The objective of my strategy is to make short-term trades based on predictions from a decision tree classifier, the logic of the trading bot. At the completion of each candlestick, feed the latest data into the model. Okay, get the prediction, that is buy, sell, hold. If the prediction is buy, and currently no position. Okay, we do not have any position for that, let's say Amazon. We just have this signal, so we are going to enter a long position, and then we will set the stop loss and TP according to the risk management rules, which I will indicate here. If the prediction is buy, and okay, the second one, if the prediction is sell and currently no position, enter a short position. We're going to short Amazon. That is, if the platform allows short selling, Alpaca allows short selling, so I'm good to go. And I will set also the stop loss and TP accordingly. Okay, if the prediction is hold or the same as the current position. Okay, that is, I'm saying if my position is buy, then I'm going to hold. Okay, I'm going to hold. Adjust the, okay, yeah. So this is it. I'm going to maintain the current position. I will adjust the stop loss and take profit if there is a need for that. The order type is market order. As I said, once I spot the opportunity, I'm going to go into the trade. Risk management, I assume initial capital is $10,000. I will put 2% for each trade, and then I will use the ATR, okay, average to range, to set my stop loss, maintaining a 1 to 2 risk reward ratio. So I told it, let me know if you understand this before we move to the next step. Told me these things here and what have you, and told me this. So if you have any things, this, we can then proceed to the next steps such as implementation, coding, or any other. All right, so this is it. We are done with this step, which is to build a strategy. We are happy it understood our strategy. Next is the machine learning process. Okay, so I will tell it, okay, the next step is the machine learning process. Okay, so what did I say? Okay, this is the process. Data collection. We are going to get market data 1 year, historical data of 30 minutes. We get the open of the Amazon, high of the Amazon, low, close, and the volume. Okay, then we are going to fetch inflation rate and interest rate data to align with our data. What we have, we synchronize everything. Then we will do some feature engineering. From this OHLTV, we will get the RSI, MACD, and Bollinger Band and various averages within the market data. We will now use macroeconomic features, that is inflation rate and interest rate. So not only are we using technical analysis or technical indicators, we also have macroeconomic features. Of course, if we want, we can also add fundamental analysis into the picture, where we add, let's say, price to earning ratio and stuff like that. We will process our data, put everything to form the model input. The labeling, how do we do the labeling? This is the threshold I told you about. We will set a threshold of 1 to 2%. So if, let's say, Amazon is $100 and we are predicting, okay, that it is going to change by 2% in the next 30 minutes, meaning that now it is 100, maybe in the next 30 minutes it will become 102. Therefore, we would like to buy now that it is 100, so that we can get our $2 profit. Or if it is going to drop to 98, we would like to go into the trade as a short sellers, so that we can also make the $2 profit. And for the logic, I told it this is the logic that it should follow. I want it to train the decision class within the scikit-learn library, perform some validation, and what have you. It's still writing, and once it finishes writing, it will tell us, yeah, so it says this is well structured, covers all necessary steps from data collection to model validation. It is breaking it down. Okay, so Yes. And also, if you want, you can tell it to avoid all these explanations. And just tell it to just give me the code and do not explain stuff, please. Sometimes it explains things until you are tired of reading them. So sometimes just tell it, just do this, and I do not care. So I said, next I want to backtest this strategy. I describe above using the best trained decision tree model and the collected data over the past 1 month. I want to print the number of times I go long and short, number of times I buy and sell, okay, exit, number of times I hold my trades, number of times I didn't trade, the return in percentage and the return in dollar. Assuming my initial account balance is $10,000 and I maintain the risk management I mentioned in the strategy, write me the code. Furthermore, use this backtesting approach to simulate this with the historical data set, record it trades performance metrics. I want to evaluate this based on profitability, maximum drawdown, win or loss ratio, and other relevant metrics. Okay, generating the code for me. So if you are seeing things like this, that means you are not making money, you are not losing money. Return in, you didn't get anything. You were able to execute 35 longs, 46 shots, okay, and nothing happened. The number of times you didn't do anything is just 82 times, okay. So we didn't buy or sell. Maybe most likely we went into the trade and it didn't give us anything. So the good thing is you can copy this and tell it what you think. You can tell it, okay, when I did the back testing, I got this result. They do not make sense to me. Can you explain it? You'll be able to do that. Because with time, you have time, you can furthermore help to keep on working at it, and you'll get the code eventually. For us, so those who have already known how to program, all we needed was to get the skeleton, and we can be able to look at the logic of the code, see where it is getting it wrong. Okay, this speeds up our work immensely. Something that normally takes you 3-4 weeks to do, you can do it in 1 day or 2 days. If you are lucky, maybe 1 week in the worst case scenario. Okay, giving me things to do with lots of placeholders. I don't like that. I can tell it, okay, thanks. Okay. So this will allow you to backtrack. Now this code it is giving you is the last code. By default, you should have it on a separate notebook. Okay, just go to a separate notebook and have it there. Okay, but for the sake of this, I will just have it all in the same notebook, and I will be adding stuff. This part I already have it, but for the sake of this, let's go and copy our details up there. Where are the details, the API keys, and the script. Yeah, so this bar set is related to the version, okay, because of the version of Alpaca Trade. Now, so if you are running the version 2, you have to update this. So it is gonna change the code to work with the get bars and avoid the get bar set. And it says this is your common error, what have you. It's not available in the Alpaca client you are using, which is fine. We do to change this in the API version and what have you. So it is updating the code accordingly to fit with my version. This code here, paste it. So as I did, if you get errors like this, just change it. Okay. It's also gonna be now execute order invalid format 30 minutes. Copy this. I don't know if you are able to follow, but we could have finished this a little bit earlier. I will send this code for you. It's gonna be made available, okay, in the resources section of our app, right? So everything will be made available, the lecture note, the prompts, and everything. So, oh, we are out of time. Okay. So I can stop here, but this should work. So are there any questions? Because this is going to work now, hopefully.
I have questions, but I could just go back through the video. Once you post it on YouTube, I'm gonna go through it before I bombard you with questions.
All right, awesome.
Yeah.
Yeah.
It helps me also learn more.
All right. Quick.
All right, so let's quickly go back to the presentation while this is still generating the code. Okay, so we are done with this, and we did the building of this. So is the question and answers. After watching the videos, I welcome your questions. If you have some of them that are quick, which you can ask now, you can ask. So what's next after this? We are going to do the last session of this week tomorrow, where we're going to see how clustering is also used in this regard. The week after, we are going to look at reinforcement learning. But before we do reinforcement learning, we will look at deep learning. The last week of January, we're going to use some natural language processing so that we can be able to read some news or some social media posts to understand the sentiment. So this we call it sentiment analysis. We want to understand the sentiment of people about a certain asset. Okay? And to get the resources, you have our YouTube channel. Just type Asat Academy on YouTube. You can get the videos. Normally we upload them 1 week after the workshop. And we have our own application as well, which is as you can see here. You can get the workshops, class sessions, and everything for free. We normally upload the content in our application. Within 24 hours, you will get the videos. Resources, you can download it for free from the app. Okay?
Hold on 1 second.
We have some premium features in the app. For example, it comes with a teaching assistant, real-time feedback on assignments, practice quizzes, and so on. We are adding more features every day, working on them. For now, they are free. You can use them because it is still in the alpha version. We are testing the app. Okay. For additional assistance, you can book a call, 30 minutes call. I will send this link in the chat. And you can use this link to book your 30 minutes call. If you have any question, maybe after following along, you can just send your question to this. You can book the meeting and you can ask your questions. All right. So with this, we've come to the end of today's session. I've taken 10 more minutes of your time. I hope you don't mind. That's because I wanted you guys to be able to follow along as I do the building process of the bot. So if you have no question, you can call it a day, and see you next time. Okay?
Thank you very much. Okay,
All
bye-bye.
Bye.